Uh, Hi guys, number of closed islands. This problem is a very straightforward problem, but there are a lot of things that we can learn from this. Uh, since this is a graph problem, it's not even a spoiler, it's very evident here from the problem statement itself. This one just works on the essentials of graph problems such as DFS and BFS. We can solve this using either of the two. I usually would prefer DFS, and that's what I'm going to show you in this problem. But if you see in the topics itself, we have a couple of different ways to solve this problem. Union find is a very interesting one, though not used very widely, but today we are going to see DFS because due to the nature of the problem, DFS works really well in this one. Basically, if I take this, uh, right, this won't be large enough. All right, yeah, let me take the pen out. So this problem states that we need zeros are islands and one is the borders which closes these islands. We need to calculate the number of closed islands. So we need to calculate the number of islands, which means the number of zeros, not the number of zeros, but groups of zeros which are surrounded by one, and we need to count the number of those groups. Right. So here you can see that this is a group which is surrounded by ones, which are here. Not really. Yeah, this one, this one, this one, this one. Right. So these are the ones which surrounds this group of zeros. That's why this is a valid closed island. Similarly, this one is surrounded by this one, this one, this one, this one. If you would see, I mean, through the perspective of one, you will think that we need to traverse diagonally, but that's not the case. You have to see that from the perspective of zero. And then you will realize that we just need to check the four directions. That's how we will find the closed nature of that island, if it is or not, right? And lastly, zeros which are on the borders, those are not valid. I don't know how explicitly it's stated in the problem, but those are not valid, and those shall not be counted as closed islands. So we can just traverse the one zeros from uh, the the grid apart from the borders zeros, because we don't even need that those are invalid, and we can do a DFS on that. And as we DFS, we change the values of zeros which we traverse from one DFS to ones, so that we don't do we don't end up in a cycle or something like that. Okay? So we can change it to one, and if we encounter a one, then we return true. We can have a boolean return from the DFS, and if we encounter a zero on the border, that means it's not a closed island. We return false. So it's a straightforward DFS. Let's see if we can code it up quickly. So we are given a grid. I'm going to traverse the grid I less than grid dot size. Here I will change one thing, the one, because we are not traversing the borders, right? That's why. And this one, j is equal to 1, j less than grid 0 dot size. This is my inner loop. I don't know why the second bracket is not coming out. Okay. If the DFS, or if the grid of I and j is equal to 0, in that case I will do a DFS which will return a boolean which will be checked here. I'll pass the column and row values and the grid as well. If it is returning true, then I will increase the answer. I'll have something called answer at the top. This will contain the number of closed islands, and eventually I'm going to return the answer. Here my DFS will be of Boolean return type DFS int row comma int column comma grid, which will be a vector of vector. Here it will be grid if it's the invalid case, where we can still have an invalid case even though we are not traversing the row, the borders. Since we are doing a DFS, we can obviously reach the border value as well and beyond the borders as well. So we will just check if it's equal. If it's reaching that point, then if it's less than 0, then it's outside. If it's greater than grid or size, then again it's a invalid scenario. Similarly, column is less than 0 or column is greater than equal to grid of 0 dot size. In that case, it's invalid. I'll return false. If the grid is having a value 1, in that case, I should return true. Right? It's a closed island. That's good. Right? Otherwise, I'll traverse the 4 directions. For that, I will have a vector of vector having the 4 directions like +1, -1, and those stuff. Let's see, that will be something called direction, and this will be having 4 values 0, 1. Let me just copy that. Second value, third value, fourth value. Fourth value, second value will be -1. Sorry, let me just do that correctly. 1, 0, 0, -1, -1, 0. Alright, so this is directions, the 4 directions that I will traverse here. Here are size. Alright, I get the new row from the direction and the row value, row plus direction of I 0, and int column, column plus direction of I 1. Alright, this is how I get the new row, new column, and I do a DFS, but DFS is returning true and false. At the end, I will have to return a Boolean value, right? That will be something of this sort. I'll have a closed closed variable which is Boolean. Initially it will have true, which means all the zeros that I'm encountering is indeed a closed one. And also I'm going to mark, since I'm here, the row and column is valid at this point, right? So grid is 0 and I'm visited it, so I'm marking it to 1. So then next time I get this 0, I will return true from the above condition itself. Closed and is equal to the DFS of the new row, new column, and the grid value, and I'm returning closed. Right, so this is the code. Let's see if this works. Oh my bad, I missed this one. Let's see now. Okay, this should be greater than equal to. I think should work now. Alright, it works. So let's submit. The time complexity will be Since we are traversing all the nodes at most once, I believe it should be of m cross n, and the space complexity will be O of 1 because we are not using any extra space, though we are using stack space if we need to count that. Let's see if that's fine. Yeah, that is correct. This is a good feature of Leetcode, but unfortunately only for subscribed members. Thanks. That's the problem.